Boh.
Ich glaube, ich mache es normalerweise mit den Arrows.
Ok, si può partire. Si parte senza aspettare conferme, giusto adesso?
Clic, clic, clic.
Sì, sono partito senza tu.
Perfetto. Hello everybody. So we'd just like to introduce Mr. Wassibauer and Mr. Leidel. And I just leave them the word. And so, welcome.
Thank you. Okay, we're going to talk about bootstrapping startup with Django. We have bootstrapped Gitsy in the last year using Django. I'm the co-founder and CTO of Gitsy.
And I'm the technical lead, basically working together with the developers. Besides that, I'm also the open source evangelist, so being a Django core developer, I kind of push that technology. That's what we're going to talk about today.
Mm-hmm. So when you start a startup, the first question is always, what language do you base it on and what framework do you base it on? And it has many implications on why and how you're doing this, because recruiting it really affects every part of your company in the end, from recruiting to what packages you can use, and at the end also how your framework embeds into the modern web stack. But after this decision, there are many other things to keep the company running and keep the company running fast. And that's a lot about culture, testing, automation, and how you grow your infrastructure. In this talk, we're going to talk about how Django, in this case, embeds in the modern web stack. So many of the decisions that we made were based on the product that we have. Gitsy is a marketplace for tours and activities. Anybody can host and book activities, and we take away the risk from both sides. We take a similar approach in Airbnb, and we take the money from the people, and then we pay the people out afterwards, the hosts out afterwards. The website looks like this, and when you look at the activities, you can go there and you can see what the reviews are and book it in the end. So this actually means that we have a big community team, and this was already one of the factors that I looked at, because we have a big community team. They need access to the backend data, and Django already comes with the Django admin, that it's easily extendable, and that was already one selling proposition of Django, because it saved us months of work just getting the community up and running. Then there's a big community. I already had a big network in the Django community. So if I would have done it in Ruby on Rails, it would have been very difficult to get somebody on board like Yannis, for example. I really like the Python language. It's very easy to teach the front-end developers to write the template tags and just like get everybody involved, really. Then many problems are already solved in Django. That's actually the part that Yannis will also talk about in the coming slides.
So specifically, what is actually the reasons? What are the reasons why we actually chose Django? I actually came on board a little bit later after the prototype was built, but that said, there are a bunch of reasons, such as, for example, that we have a proven track record with Django in huge sites such as Pinterest, Instagram, where we basically know that they have the same kind of technical profile as Gitsy has or will have, I mean, depending how you see it. And Django provides us, as in a fast development world, in a startup world, with a required stable release process. So in that sense, when we do in Django, when we do releases in Django, we always make sure that we have a sensible migration path, in the sense that we don't break stuff, don't break APIs, and if we do, then we at least document it well and make sure that the sites run smoothly. It also means that we have a very, very tight and very strong focus on good documentation. It helps us, in case of Gitsy, or I think in any other startup, to be able to bring new developers on board, to actually teach them or educate them while working on problems that we have every day. And as Philip already said, we have a very fast-paced product cycle. So we work on a lot of projects side by side, and that's where bringing in new people is a very important requirement. And lastly, of course, and this is actually the main point I'm going to talk about a little bit more in detail, is the huge community of third-party components. It's in March, I gave a talk at PyCon US, and I was looking at the numbers and how many apps, reusable apps are out there on the Sheath shop. And I think the number was about like 2,100. And earlier today I looked at it was like 2,600. So in a matter of months, we still have a huge number of new developers releasing software which implement like the features and the abilities that we require as a startup, where we can like go in a shop and pick the best things out of it. And if nothing actually fits our requirements, we just leave it and write it on our own, or actually in this case release it on our own as well. But to show you a few examples, I want to go into 4 examples which are very important for us as a product, which are paradigms that we require, and it's kind of a pattern. I'm going to come to that a little bit later. First, I want to talk about search. It's in every modern web site. It's an integral part. It's without a sensible search, nobody is going to go to the site and actually, enjoy the content that is hosted there. And for this reason, actually, we chose Django because there's a very stable and very well-known tool called Haystack, which you may know probably, some at least. And the simple reason why we chose it is, for example, in contrast to just go with using search indexes directly, such as Solr or like the embedded Google search index and stuff like that. It's that we can write Python, we can integrate it with our Django application, and we can extend where we need it. We not only get a bunch of like built-in tools such as like indexing, filtering, and faceting, which are very, very strong paradigms in the search world. But we also get the ability to do whatever we want to do with the search. And this is a very powerful tool to extend it. For example, maybe if you go later on the site and see the city page, that's based on search technology as well. We don't promote that very much, of course, because it doesn't have a search kind of UI yet. But this is something which is we're already profiting from. And we didn't go much into detail about what Gitzy specifically has, what kind of plans we have in the future. But spatial search and spatial data is very important for us, of course, as well. We have lots of events all over the world, and people enter there not only in cities and in areas that are easily locatable, and that's why we need a very flexible framework, which allows us to give the user the list of events in a remote area, and this is where Haystack actually is great. I should note this is a feature of the beta version of Haystack 2.0, but in any case, it's great. The next one, which is another very strong paradigm, which we require especially for our user-facing UI, is the Sensible Web Service API. I'm not going to say REST API because that's a very tricky thing. But so in this case, for example, if you go on the site and want to enter a new activity, you want to host something, then you will actually see a screen which doesn't actually behave like the common Django app, where you have a view that processes some form data and then actually spits out the good response for it. But instead we have a backbone-based UI, which I'm not sure how many people know Backbone or have used it. Okay, so I'm not going to tell much about it, but for those who haven't, it's basically a layer where you can have an MVC model on JavaScript side. You have representations of data models in the JavaScript. You can very easily change, update, delete stuff directly from the browser without having to go through the whole request response cycle of standard Django views. It's we are using it specifically for stuff that shouldn't be that shouldn't act as a I mean that has a very high value for us. I mean I was saying that it's the activity editing view, for example, is very important for us. So we want to have the best user experience for our users. And TastyPie brings exactly that. It's again just like Haystack, a great abstraction where we can hook into very easily, where we can write code, where we can write view code without having to maintain the abilities of TastyPie, such as, I mean, you see it on the slides, that they're not only like authentication and throttling, but actually there are a bunch of other things such as custom serialization, which we may need if we want to hook into other web services that provide event data, for example. There's, in other words, again, this is the pattern we see a lot in Django. We have a sub-framework which implements a very strong paradigm, and we can hook into it without having to rewrite all this stuff. The third one, which I think is very important as well, because as you probably know, like a slow site is a annoying site. We want to be fast for our users. We want to make sure that every page view, it's a pleasure to have. I mean to see. And task views are the great way to actually handle exactly this. I mean, you probably know this. Asynchronous code execution is a simple way of making sure that if something happens on the front on the user-facing site, and you run something through Ajax, then we don't have to wait to something to happen. I mean, especially like search index updating, for example. I mean, which means that if we have an activity and the search index needs to be updated because something changed, like the title or the description, we shouldn't wait for the search index to actually do that kind of thing. But it's other than that, we also use it in a very cron job kind of way. We have a few periodic tasks that we run all of the time. I'm going to go into this a little bit more later, but it's mostly very useful to shove it on a separate server, not thinking about it, because the most important thing is that the website serving server is fast enough for this stuff. It's, and also, the third point, I think this is a very interesting thing, which Philip is going to go into detail later. This actually, Celery allows us to collect statistics very easily. So, for example, if you want to make sure that if a user comes on the site and clicks a certain funnel through the site, then we can actually collect each of those data points without actually the user noticing, which is great for us to make sure that he's actually clicking on the right things, and we can change very easily because of that. Another great reason. And the last point, and this is more or less not a really third-party component. Obviously, it's built into Django, but like caching is kind of the bee's knee. You know that sites can be slow if you have complex data or complex database queries. It can be a pretty pain. In that sense, we are using it in a different way, though. I mean, there's not one way of actually doing caching. In this sense, for example, we are using Celery for periodically updating a few parts of the site. So maybe you've seen the front page where we have those images. Those images are periodically updated in the cache, for example. So it's kind of a simple way, very stupid way of making a little bit randomization on the front page. So by doing that, we can make sure that the front page never actually hits the database at all. And the same for so-called fragment caching. It's a great article on the weblog of 37 Signals a few months ago that we applied to Django. Thank you to Django. We can actually have a very easy way through the cache template tag. The point in this case, though, is that we have, for example, in the activity models, a special field. It's called the refresh date, which we use in all the cache keys where we that we use in the templates. By that, if activity is saved, I mean, if it's changed, for example, by a user, then it automatically invalidates throughout the site because we rely on the fact that this one cache key is the one we use. That said, in a part of this site, we also use specific cache versions, and that allows us to, for example, to decide during deployment that we should actually invalidate this cache because it may have changed something in the data model behind it, or the template was changed that renders a certain part of the site. Django all comes with it. Memcache is a it's a natural match for this kind of feature. We've been using Redis before that, but weren't super happy about it. Memcache is just stupid and simple. It's good. Cache warming, another thing which I learned over the last years, is a very useful tool where we write basically scripts during migration, during deployment that migrate the cache. If you want to see that like that, it allows us to have the cache ready before the new version of the site is actually online. It's something which we want to work on, and I think there's still, for example, some space where Django itself can be improved in that regard. But I think it's worthwhile. So to summarize, I think to actually coming back to the idea, there's a strong pattern there. We have framework-based, or we have very abstract-based solutions out of the broader Django community, which we use to be very, very fast in development. We don't have to think about each of those things where we don't have to be super fast in certain queries because we can rely on the fact that Celery is taking care of that. And I think this is one of the major usefulness of the Django ecosystem. That, of course, there's in the broader Python ecosystem there are other solutions as well. I wouldn't dare to, not say that, of course. So the next thing I want to talk about a little bit, because this is basically my kind of task at Gitzy, is making sure that we, as a team, as a developer team, which often has changing positions, and we have new developers, maybe sometimes not with a Python background even, but we want to make sure that with all the different kinds of products and features we're working on side by side at the same time, that we don't fall over each other, basically, over the work of each other. And that's where we adopted just recently, actually, the GitHub workflow, which is great, and I want to praise this. It's very simple. It's like, again, keep it simple.
Yeah, we came from using Git Flow in the beginning, which was a very complicated kind of release cycle, especially when you deploy every day.
Exactly.
So we switched to the GitHub version, and it's amazing. It improved our code and the speed in that we work.
Exactly. I mean, the main point is of every work we're doing is that once at the end of the day, we want to make sure that the master, which is kind of our main branch, is deployable. So that means that even the work on templates that are more graphical related should be ready to roll. And if they are not, if they are much more complex, then we always want to make sure that the development happens in separate branches. It allows us to make sure that each of those features don't break any part of the site. You probably all know this, but it's such a simple thing, and sometimes it helps during the day, like in the day-to-day work, to prevent any confusion. Also, code reviews is seems so simple, but it's a great way to make sure that the code quality stays high. And it's in the end, it's really about shared responsibility. We as a team, as a developer team, either front end or back end or just ops persons, we all need to make sure that the product we are working on is in a shape that can be deployed, and that's where I think is that kind of workflow great. The next part, though, and this is of course like a threaded topic, is testing. And this is, yeah, in the world of startups, kind of it's an odd situation. Obviously, you want to have a site that always works, that like the core components are well tested, and that's where we kind of try to work at. We're not going to test each and every view rendering because we know that Django tests this, for example. That's why we try to separate a few things. In this case, we try to separate between fast tests that can be run on the development machine, like by every developer, and the slow tests that are functional or integration tests that are like using Selenium that run on a CI server, which we like after each of the push. I think we have each push.
After each push.
Yeah, after each push are actually executed. So we are always aware that if you change something in the code or if we merge a new feature, that that the site is still running. It's right now we are using Jenkins for this, but I've been closely working together with the Travis CI guys. In case you haven't looked at it, it's great. You should really look at it. It's just another service, basically service-oriented test hoster, whatever. But it's yeah, really it's not important what kind of tool in this case you use. The important bit is that you always know what actually happens when you change the code.
One thing about Travis CI though is if you switch to the GitHub flow, it actually tests all the pull requests that you issue. So you actually know before you actually merge something in that this is already working. So you don't have to find out later that you just merged in something that breaks your code, which is a really great feature and will work very well with our environment.
Yeah, I mean, although this is just beta, right? I mean, it's not. I think it's. You still have to actually ask for having this feature.
Yeah, but it's coming soon.
Yeah, it's coming soon indeed. Well, okay, so I think this is kind of, I'm not going to go too much into detail about what testing is or stuff like that. It's a huge topic, but it's super important for us because another way to make sure that our product is ready for the real web, basically. But like the third point I want to talk about in this day-to-day kind of problems is that what kind of tools and workflows we use for the release part. So Gitzy as a code base, as a Django project, if you want, or as a collection of Django apps, depending on how you want to look at it, is a standard Python package. There's a setup UI file, so we can actually install Gitzy itself. We have a very strong version story, so we will always increase the version number and stuff like that. So it's like such small things help us to always make sure that we are on top of what actually is running on the server. We're using virtualenv and pip to actually install those all the requirements of Gitzy as on the development machine as well as on the server, of course. But for few of those packages, for a few of those requirements, we actually have our own package index. So PyPI doesn't support that kind of thing, and so we actually chose in this local shop, which is also just a random Django-based project that you can host. But there are dozens of others. The point is that you use the same workflow for releasing your own software as if you actually use the other, like a third-party component. I think this is very important. It's a you shouldn't make any differences in between those packages. Then we use Django ZCon, which is right now unreleased project. I hope to get it done at some point and actually have some documentation ready. It's more or less Django app, which helps you to get rid of this awkward Django, the module-based Django settings problem. It's like it helps you to write class-based settings, basically. Like hat tip to Matthew, who wrote Django class-based settings. That's kind of the. Anyways, the point is, it allows us to be much more specific about how our Django environment is set up. It's a great way to do that. And we are using Foreman for process management. It's if you maybe use that, it's similar to Supervisor. It's written in Ruby. It's great because it has a few features that we like. For example, it can export those configuration files to different kind of server instrumentations, frameworks such as init files. So all in all, not very exciting tools, but combined with each other, it's actually very interesting to use them.
The important thing about Foreman, though, is if developers want to have a local stack that has the Elasticsearch running, that has the server running, the memcache running and stuff, it's one command, and then everything will be running. And we don't use a virtual box or anything for this, since that takes long. It just slows down the process. So we actually install this on a different operating system, but then we have one process manager that actually starts all of these things with one command.
Exactly. I mean, we of course have a few of the requirements such as like Postgres and Elasticsearch that are definitely not installable with pip. So in that case, on the development machine, we use a native package installer. So it's on macOS, it's Brew, and on our servers, it's apt. And in that sense, all those tools I mentioned here are more or less about the Python requirements, if you want. I'm not sure how you want to call this difference, but anyways, we are not using directly like Ubuntu tools for that, and VirtualBox, I don't know. So to summarize those three steps, how we work on a day-to-day basis, how we do testing, and how we actually release each of those components, how we release each of the updates, I think that helps us to be fast and quick and change a lot of the stuff without breaking stuff. So
this pretty much wrapped up how we work as a team. So then one big part about startups is how you actually scale up your infrastructure. So initially we had our website up after the first day of working on Gitsy, just a simple form where people can submit their emails or can say they want to host something. So initially we just did this by hand. We just had one server actually, we didn't think that there was going to be a lot of traffic. There wasn't a lot of traffic, so it worked perfectly fine. But once you start scaling up, things start to get a little bit more tricky. As Yannis said before, now we have Celery installed. We also have a load balancer. We have many web servers in front. We have Redis that does our queues, and we have Memcache that does the caching, and then we have a master database and slave databases in the back. So if you want to set this up by hand, you're going to repeat yourself a whole lot of time, many times, and you're going to make mistakes, obviously. So that's a big problem. Besides that, though, there's also the problem of deployments. So if you have, for example, a Fabric script, if you have one server, it's pretty easy. You just say install it on that server. It gets the newest Git release, it runs collect static and migrate, and everything is done. But once you have more servers, then stuff gets more difficult. Which server is going to do the collect static? Which one is going to do the migrate? Should each one be doing it? That doesn't make any sense, actually. What happens if PyPI breaks down in the middle of the deploy? So your web servers have the new version, but your Celery servers don't have the new version? Or just one dependency breaks? So we looked at stuff that Etsy did in this situation, and they have this tool called Deployinator. We wrote our own thing because, it's not hard. It's not too hard to write. It's a central server that really takes care of building your new release. It builds the release and puts it in a tar, and then all the other servers that you see here, the Celeries and the Webs, they can get your latest release. So that takes care of certain parts. It builds the whole thing in a virtual env before it tars it. Then it puts it into a folder. Then it tells all the web servers and the Celery servers to get the new version in. Once they have the new versions, we know that we can now do a deploy, and then it does an orchestrated, automatic, atomic deploy. So which means they just, we symlink the new version in, we reboot the servers, and in between that, we'd actually do the collect static and the migrate on the deployment machine, not on any of the other machines. We also are going to write an interface for this, so you have a button that you can press. Anybody in the team should be able to press it then. It also logs who is doing it, so we actually know what was the last release and who did it. And it will be open sourced very soon, and you can also do a rollback. Because you have all the dependencies, the packages in there, you can also always roll back. Furthermore, it notifies other services. Communication is a super important part for our team. If every time that we want to deploy, and we deploy more than a few times a day sometimes, we don't want to scream out to everybody, we're going to do another deploy. So what we have is the deploy server actually pushes it out to the HIP chat and also pushes it out to New Relic. So we also see when new deploys went out and everybody knows about it. So this takes care of a certain part, but then there's still the configurations of the servers. And then you come to tools like Chef, Puppet, or Salt. We started last year, so there wasn't really, Salt was in the very early development. Puppet didn't feel natural to us, so we went with Chef. It follows the dry principle too. You don't repeat yourself. Everything is documented in a repository. You can go back in time. You can see what changed when bugs hit you. You can just see what actually changed on the servers. Furthermore, you have a place where you can store secure data. It's called data bags. You can put passwords in there, and those passwords will be streamed out to all of your web servers. You don't have to put stuff into your settings anymore and stuff. Furthermore, what Chef is really good in is the roles and the environments. We were missing that in Fabric, for example. A role can be, for example, a web server, or it could be a Celery server. But you can initially actually put all of these roles onto one server. So you could actually start out with Chef and say, okay, my database, my Chef, my Celery, and my web server, they're all in one machine. And later you just separate the roles up and make a big environment out of it. Also good for staging environments, because you can just say my staging is a lot smaller, I don't spend so much money on it, but the production environment is actually pretty big. The challenge that we had was separating Chef and the deployment 100%. So when do we call a Chef client and when do we do a deploy? It's initially just a concept that you have to wrap your head around. To show you a little bit of some detail. So the configurations are mostly stored in JSON. You can also use YAML or other stuff. But so we have the web servers, and you can see here that we have our Gitsy web and our Gitsy common installed, and then New Relic and all of these other paper trail apps and stuff come on top of that. And here we also have Gitsy common, which is our main package, and then we have Gitsy Celery installed, which acts a little bit different than our web server does. And then, which is really nice, we have an environment. And the environment is really just to hook the pieces together. It really just tells the roles, okay, your database server is over there and the memcache is over there. So what would happen if we add a new memcache, for example? That's not a deployment. That's really just an infrastructure change. So if we add a new memcache, then we would add it to the environment. We would say, okay, there's a new memcache server. And then we would tell all the webs and all the Celeries to redeploy. And in the next slide, I'm going to show you how that works. If you add a new web server, for example, then the web server just boots up, it installs all the apt-gets and what it needs. It knows what version it should be on. So it just pings the deployment server and gets the newest version in, downloads it as a tar, and it's ready to go, really. And on a new deploy, there's not really anything that Chef needs to do. The deployment server pushes it out and tells the GUnicorns to restart. So if you have a Chef set up and then you install your Chef server and you have Knife configured, you can actually get a really nice way of handling your service in the cloud. So to start a new server, instead of going to the AWS console and using the interface, you can actually just say Knife EC2 server, create, and then you can say the name of the server. So this is actually how we're going to be identifying it later. The role that it has, in this case it's a web server. Then that it's in the security group, staging web. So our staging webs are allowed to communicate with the database, but other servers are not, for example. Then what environment it has. In this case, it's a staging environment. So if we would put this in production, it would actually be talking to production database. Then what AMIs we are using and what size of server we want to boot and in what area we want to boot. You can actually make this a lot easier, smaller too, by just configuring your knife.rb, and then certain things are just defaults and you can override them. So then, once you configured your servers like this, on the console you can just see which servers are running, which servers with what role are running, and then you can knife SSH all of them, for example. You can say knife SSH the role web and do a sudo chef client. A sudo chef client means that it runs chef client over it, configures it new. For example, if a new memcache comes in, then you would be doing that, because it would add the new memcache to all the settings and then reboot all the services that are in contact with it. And then in the end, if you don't need a server anymore, you just have a 1.2 and you delete the server and it removes the node and everything. So this is really useful, especially when you have a lot of servers. I think we have like 8 or 9 of them running at the moment. It gets really tedious to do this by hand. And if you do it like this, it's actually quite fun. And also the great part about the first line is you can just click it and take a coffee break and come back and the server is ready for you. Then there's a tool that Instagram wrote. It's called EC2 SSH. One problem with the Amazon EC2s is when you reboot them, the URL changes, the IP changes. So if you actually want to get an SSH access to it, you would have to write like the top command. And you would always have to remember which one is the new one. It's not intuitive named. You saw in the previous slides how we name the server. This one is now staging web 1, for example. So with EC2 SSH, I can just say log me in as my user on production web 2. And this never changes. You decide what the name is, and you get there really quickly. Then there's PyChef. So we are using Fabric for the deployments, and there's a PyChef that hooks neatly into Fabric. Instead of then, same problem as before. The IPs change, the URLs change. So PyChef actually just abstracts this. You say, I want to deploy or do certain tasks to all the web apps. And then it will actually ask Chef which ones are the web apps and then do the commands on them. Then I come to operation and metrics. We log as much as we can, and we do, like Jannis said before, with Celery, we do a lot of statistics aggregation. We use as many services as we can, because just keeping up with all of this and building it yourself it would be so much work, and we are much faster of just using these services. For example, Mixpanel we use for retention and really monitoring what users do on the site. New Relic is really server monitoring. It's a great tool. If you have the money, I would definitely advise you to use it. Librato is a graphite tool that just manages your graphite graphing logic. Papertrail takes the logs of all your servers and puts them in one UI that you can query on. And PagerDuty pages us when something goes wrong. So we have screens in our office and we display those metrics there. And we use this app called Django App Metrics. We can push data to one or more backends. So it's one call that we do, and we can say push this to Mixpanel, but also push this to Librato. Because some stuff you might want to have retention and user management and monitoring, but you also want to have it in Librato to just have the normal graphing. So this is how a Papertrail log looks. So here we have all our Celery tasks, and you can see in the bottom you can just query for production, Celery, task sent. It's as easy as that. It's really powerful because you don't have to look around on your servers anymore. Other thing is it can send you alerts to PagerDuty if something happens, which is quite nice, and it can be aggregated to Librato. Librato looks like this. So we have the signups, activities activated, and all of these statistics. And if you look, the tasks sent are actually the ones that show up there. And also,
these are out of the box, or you must configure all of this, because these are standard ones like sign-ups.
We can do this in the questions in just a second, yeah? Yeah, so things that we have learned is to bootstrap your startup really quickly is only scale when you really have to, but be prepared, for example, with a chef recipe. So you can just say, okay, the memcache that was on my server before, I can just move it over there. Automate as much as you can. Really, it's just doing repetitive tasks. You always make mistakes and they just drain your time. Be pragmatic. Use the tool that's best, that has the biggest community. Use continuous integration and do continuous deployment. Deployments get a lot easier when you do them every day because you do small changes, stuff doesn't break as much. Make routines tasks as easy as possible, like the EC2 SSH or the chef, and display the metrics in the office. We are still looking for people at Gitsy. We're looking for a web development and backend and operations engineer. And that's the end of it. Questions?
So, any question? Just a moment from the front.
So actually I have two questions. The first one was what I've asked, if these kinds of statistics are the standard one that you have out of the box if you install this Django app, or you must configure it?
No, it's really like Graphite is great. Because Graphite, you don't have to configure it. You just send key value pairs against it, and it starts graphing them. So you have to set Libretto up and then install AppMetrics. AppMetrics already has the Celery backend installed. So you just call this one function, log it there, you're done.
Okay, and my second question is to this. You shown us on this automated process of building environment and pip install and so on, something like that. But how do you solve the problem if you got just write a single class that do something like a class-based view that is handling form set because it's not in the Django right now, or something like that, and it's a general class that solves some problem, but it's not so large to put it in the package by itself. So and possibly you will use it in the many projects. So how do you deal with the class on the very slow granularity if you want to have a very nice install like a package, but not like a PyPy package, for example?
So this is pretty easy, and it's a very common question indeed. PyPI is, I mean, we should all be aware that distro-tools and setup tools as ways to actually package Python tools is a general tool. I mean, PyPI is just one way of actually distributing those things. So in other words, we have a bunch of utilities that we just throw into our, I think we have Contrib, I think is the name. Mm-hmm. It's like, I'm pretty sure that everyone has that. It's very like a core module. Yeah, exactly. So we definitely have that as well, but some of those components we definitely package up as well if they have a more common utility, and we put them on our own index. And it basically fits the bill as any other package we have on PyPI. I think we should all be encouraged to use those techniques and technologies to not only release open source software, but also do our own releases internally, if you say so.
So, just a moment.
Hi, you said that one of the reasons why you chose Django was the large community based around it. In the United States, people are saying that Django is a great system, but they have difficulty finding people to work on it. Do you think the situation is substantially different in Europe, and what are we going to do about this? How do we get more people into the Django community?
Yeah, I actually think that the Python community is very big. Django, if you compare it to Ruby on Rails, for example, is definitely smaller. Everybody can see that. But in the same time, there are not as many people fishing in the pond, I would say. Like, for example, in Berlin, there are just so many startups doing Ruby on Rails. It's actually, I think, pretty hard to find good developers in Ruby on Rails because they're going to be recruited by the companies. My personal in Vienna, for example, where I'm from, I know a lot of Django developers. In Berlin, I know a lot of Django developers now, but I have to say it's definitely smaller than Ruby on Rails.
Hi. About your atomic deployment with virtual environment, how do you swap the files? Do you deploy to a unique file directory when you do your virtual env on the build server, and then switch a symlink on each of the servers?
Yeah.
Okay, that's what I said.
Yeah, we have three folders where the versions are in. We have symlinks that refer to those, and at each deploy we stack one on the bottom and throw one on we put one on top, and
so
one on the bottom we take out.
The virtual environment is built once on the build server.
Yeah.
Just a moment. Sorry.
Hi, you have mentioned that you have a custom package that orchestrates the deployments across many servers, many nodes. What is the reason to roll your own instead of pushing it as a Jenkins job or to an orchestration tool like Rundeck or mCollective or Salt, for instance?
Mm-hmm. We looked at, for example, Deployinator. I wouldn't do it on Jenkins. I think that's too generic of a tool. We want to have rights management in there, and it's too targeted. Jenkins is too broad for me in that sense. We looked at Deployinator, and we looked at it for a while. We evaluated it, and we realized that we can do the same just using Fabric and the tools that we like to use faster than actually getting into Deployinator and doing it.
I see. I have mentioned Jenkins only as a part of the flow to build the deploy artifacts, and then there are different orchestration tools. You mentioned you Salt, there is mCollective Rundeck with pretty UI that defines flows on multiple nodes. I don't know if you know that or if you evaluated it. If yes,
I know Salt. I don't actually know Rundeck per se, but
thank you.
Do you?
Hi. Just looking at your collection of statistics, gathering data, are you aware of systems like Splunk?
Yeah.
Yeah. So as part of your consideration?
Splunk is very expensive. Main reason.
Yeah.
I think Papertrail is very nice. It does what we need pretty well. And then Graphite is just a way to do stuff lately. There are a lot of tools popping up in the DevOps world right now that just gather around the Graphite environment, so I think we're pretty safe with that.
I just asked because it feels a bit, for me anyway, it feels a bit...
No, we looked at Splunk initially, but it's just really enterprise, really expensive. Yeah.
Cool, no worries.
So, any more question?
There's one there.
Oh, sorry.
On top of all this system, how do you manage your issue tracking, your tasks and release cycles? Do you use any project management tool?
Yeah, so that's actually a really good one. We switched away from just the ticketing to doing projects in our team. So any bigger feature is a project, and it has one community person in it, one technical person, one front-end designer, and it's usually 4 to 5 people or something. And one takes the project lead. So they work as a unit to finish this product together. And then we use Asana. It's a new project management tool to keep track of the tickets.
Okay. So who merged the codes? How do you decide on?
Yeah, so people make pull requests, and then Yannis and I look over it and merge it.
All right. Okay. Thanks.
Oh, back there. Could you please pass the microphone, please?
Actually, everybody looks at the pull requests. Just we have the last say on it. Yeah.
Okay, so just out of curiosity, given your size of the project, how many developers do you have?
We have 4 right now. But
you think it's sufficient?
We just got 2 new ones in now, so before that it was Yannis and I. Well, it's good enough, I would say, but as I said before, we're still looking for people. So it's a big product, actually, when you look at it. There are many sites, many things that can go wrong, so we do need a bigger development team, that's for sure.
So we have time for one more quick question. Anybody? Okay.
Thank you. Hi. Everything looks very, very neat, very cool. Congrats. How much time did it need to you to define all this flow, all the products, and glue all together?
Took quite some time. Like we started last May. We launched the first version in August. We launched publicly in November. And in November, when Yannis joined, we really started defining all of these tools. And it was a lot of talking to other startups. Matthias Meyer, for example, in Berlin helped us a whole lot because he's more in the DevOps world. So we got a lot of tips from them and then just took it from there and put the rest of the pieces together. But it all locks into each other. If you do continuous deploy and CI and you do metrics at the end, it all comes together and it just aids everybody in the team and everything gets a lot easier after a while. Just initially to get into this process is actually quite a process.
Okay, thank you very much.